This conference will now be recorded.
Good morning, student. So, in the last lecture, we had seen about the different methods, right? And we have seen some methods all right. So, rational method we have seen, right? Empirical method, there are three methods: Dickens formula, Rives formula, modified regional flood formula, right? So these are the formula, and we were on the statistical probability method, right? So we had seen simultaneously, see, this is the notes. We had seen this flood frequency analysis. This is one of the method for calculating the flood discharge, right? We have seen already these methods: rational method, empirical method. Within empirical method, three methods: this Dickens, then time of concentration, we have also seen this, then Rice formula, we have seen this. Excuse me. Then there is one more method that is related to the probability, or we can say related to the statistical method, right? So here, so we were talking about the statistical probability method, right? Statistical probability method. So within that, we have seen there are two methods, right? The statistical probability method, and this statistical probability method, and one another method is theoretical probability method, right? And these all methods are the flood frequency analysis, right? This method is based for the flood frequency analysis, right? So another method is what? That is the theoretical probability method. This is already here given. I will not write. So this method is used for when we have to we have more data, right? And for long duration, right? So for long duration, we can use this method, and for short duration and data is very small available, then theoretical probability method is used, right? So we'll see this. So first of all, in statistical probability method, so first is the size of the data should be large, right? Second one is there is term recurrence interval or return period. Return period I have already explained that. For example, one flood came in 1950, right? And the discharge was say 150 meter cube per second for that flood, and the rainfall depth was say 100 centimeter. So after how long, after how many years, the same rainfall will be repeated and the same flood discharge may be occur, or what is the chances of the flood, after how many years it can repeat. So that is called as the return period, means after how many years it can be repeat, then that is called as the return period or recurrence interval, right? And it is denoted by T, right? And here this T is equal to 1 upon P. What is P? P is the probability. Probability. Probability means as the time will increase, means suppose it may be it may come after 100 years, right? So it means the probability is very less. But suppose if it is occurring, see, after say every 2 years or after every 5 years, then what will happen? If this is small, then it will be big, and if it will be big, means probability means after every 2 years, 3 years, the chances is there than this will be more, right? So they are inversely proportional, we can say. So here we were looking how we can find this. Then M is the rank numbering, N is the total data, and return period is equal to N upon M, and P is equal to the reverse of that is M upon N, right? Obviously we know that if T is equal to 1 upon P, and if I will put the value of P, P is what? In this M upon M. So obviously we know that T is equal to N by M. If I will put this value, so obviously it will be reverse, right? So we have seen this in the previous lecture. Now the same thing I have mentioned here. This is the detailed statistical probability method. This is the detail is given. Probability methods are, however, unable to give the precise result, whereas the lesser number of past records are available. When small data is available, then it is very difficult to give the precise result. Now, this is the same thing is mentioned here. Chances of flood means what? Chances, if a flood of a given magnitude occurs when an average frequency of 100 years, then there exists 100 by 100 is equal to 1% chance for this flood. Means if a flood is coming after say 100 years, so its chance is only 1%, is saying, right? So this 1% is what? Its probability. So if T is equal to say more, T is equal to more means T is 100 years. After 100 years, it can be repeated. The probability is only 1. Now here the same formula which I discussed here is given, right? So we were talking one example. For example, this data is given. For example, this 20, 60, 90, 85, 40 year. So how we can find this t value or p value or n value? See here, you will see this. If you will see this, these are some data are given, right? This is some data given here. So first of all, the method is so how to find the t value or p value for any number of data or any number say 500 or 100 year 500 data or 10, 100 data, suppose. So here, suppose the data is given as say 20 meter cube per second is occurred in some year, say 1950, suppose. Then likewise, some in some year 60, in some of the years in 90, then 85 meter cube per second, then 40 meter cube per second, then 15. Likewise, it is occurred, right? And there some different years are given. So what is the procedure first? The first procedure is we arrange them in a sequential order, right? We arrange them in a sequentially order. Sequential means in decreasing order. So data is arranged in decreasing order. In decreasing order means what? See, decreasing order means first one is which one? 90 is first, then 85. Likewise, so first we will arrange 90, then 85, then 60, then 40, right? Then 20 and 15. See, this data may be number of data, just we are taking only few data, say 19, whatever the year is there, we will just write here. Then once we have given them, say this is the Q value, right? It is better. I will use some line like this. I'll delete this. So first of all, we arrange this Q. This is in meter cube per second, right? We arrange in decreasing order. Then see, this is very high. Obviously, even in class, who is having the highest number, we give them as a one rank, right? The same thing is here. This 90 is very high, so rank is one, then two, then three, four, then five, six, seven, likewise. And see, this total number is how much? This total number is 7. So this total number is 7 means the total, we say this capital N is equal to 7, right? Because we 1, 2, 3, 4, 5, 6, 7. So that's why we say this capital N is equal to 7. Now, this is order number. Order number means this one is the order of 90. So this is what this order number is 1. For 85, the order number is 2. So it is order number is represented as, we can say, M by M. So I will say this is 1, 2, just for you, 3, 4, 5, 6, 7. Simply directly you can, even you can say directly M is equal to 1, M is equal to, directly you can say, or here you can also say M is equal to 1. Right? So you can say this M is equal to 1. Now, once we know the M value, we know the N value. And I have already told you this, the formula for T is equal to M upon N upon M. N upon M means this T is what? This is what? This is the return period. Return period. Right? If you will calculate this, then what would be this one? Total N is 7. What is that? 7. So 7 divided by this is 1. So it will be, we'll get 1, 7. Then what is 7 divided by, then 2, then 7 divided by 3, 7 divided by 4, 7 divided by 5, 7 divided by 6, and 7 divided by 7. So we will get some value, right? No. It means what? Now through this table, what we understand? What we understand, if you will see this, the value we will get here, this is 7, then how many? This 1, 2, 3, 4, 5, 6. Okay, sorry, this is 6, total 6. So here 6, it will be 6. This is only 6, right? This is for this one, this. Only 6 is there. So we will say that this n is equal to what? 6. So here it will be 6. Sorry, actually, I thought that this is 6. Right? I think it will be clear. Whatever the number of whatever the number of data will be there, so we will write that. Simply we will write it 1, 2, 3, 4, 5, 6. Suppose there are number of data, for example, say 10, 9, or some 7 or 8. So what would be this one? This one will be 7, this one will be 8, this one will be 9. Likewise. So just it is for your understanding. So here only we are taking only this 6 number, right? If we will, so it will be what? 6, n is equal to 6, right? So that's why 6 divided by m is how much? M is this, for this 90, m value is what? 1. So here 1. For 85, m value is what? 2, right? This is 2. For this, likewise. So 6 divided by 2, 6 divided by 3, 6 divided by 4, 6 divided by 5, 6 divided by 6. Then we will get this some value, and you will see that for this value, this 6 divided by 1 is what? 6. And this one is what? 3. This one is what? 2. This one is what? 1.5. This one will be 1.3, and it will be equal to 1. So here you can see that the maximum discharge is of 90 meter cube per second, right? But it can occur after 6 years, right? After 6 years, the chances is less. Here you will see this 15 meter cube per second is the chances of 15 meter cube per second is it can be repeat after 1 year, right? So here, as this value will be less, this will be more. More means the chances is more, right? And this value is less, the chances of repeating the flood is more. I hope this will be clear to you. So this is called as the what we call, this is called as the return period. There is some more terms actually. If you will see this, what are these more terms? So here you will see these more terms are what? See, after that is one of the method, right? One of the method, and another after that. This was the initially given. Then after, what happened? Some of the engineers from California, that is they given some formula, and that formula they given that P is equal to m upon n, right? Initially, see, initially what we have seen that T is equal to what? N upon m, and P is equal to what? M upon n. So this is called as the California formula. Now after that, we have used this one, right? But after that, this one of the scientists is called as Weibull's equation. He says that no, T is equal to not n upon m. T is equal to n plus 1 upon m. He given this method. After that, again, United States Corps actually they suggested no, T is not n plus 1 by m. They said that it is n upon m plus 1. So they given this formula. And after again the US corps, one of the scientists Hazen, he came and he said that no, this t value is equal to not that n upon m plus 1. He said that this t is equal to n upon m minus 0.5, right? So different scientists given the value of t, right? So first we use this formula, that is the California formula. Suppose I can ask you in the paper, find the return period. For example, I am telling you, find the return period using all formula, using California formula, using Webull's formula, then using US Corps formula, right? And using Hazen formula. So, so you should remember this formula, right? Now, there is one more term that, see, event means that flood may be occur, that may be, and that may not occur, right? So here, the one term is there, that is the probability of not being occurred. Probability of probability of not being occurred means what? Means what is the chances of what is the chances that the flood will not come. So in that one they denote it, probability of not being occurred is denoted by q, small q, and this small q is equal to what? 1 minus p. And what is p? We have already seen this. P is equal to what? P is equal to the probability, and probability we have seen m upon n, right? So they have given, some of the scientists, they given this formula, right? That is the probability of not being occurred. So here there is a, means a number of, we can say that formula, you will see this formula here. NCR P raised to power R into Q raised to the power n minus R. So just you remember this formula, that is sufficient for you, probability of not being occurred. Now, here the same, you can see probability of the event occurring R times. Now, this first, there is two terms. First, probability of not being occurred, right? Here you can see probability of not occurrence. If you will see this sentence, probability of not occurrence is, you will see probability of no, its not occurrence means what is the chances that flood will not come. So in that case, this is the formula. Then another binomial distribution is given, that probability of event occurring r times means, once say r times means after, say for example, r, if I will take r is the 0 means if I will put the value of 0, r value 0 in the this formula, and this formula, right? So I will get the formula will be equal to, no, first thing you should clear that this q is equal to 1 minus p means probability of not being occurrence. Now this is another term, that is what, that is another term is reliability. Reliability means how much percentage we can say, or how much we can rely. We generally in our day-to-day life we say that we should rely on that person, we should not rely, right? The same reliability is there. So reliability, for reliability the formula is this one, right? For a reliability of flood, when we have to find the reliability of the flood, then we use this formula. If I put this formula in this formula, R is equal to 0, then I will get one equation that Q upon N, Q raised to the power N is equal to 1 minus P raised to the power N, right? So this is for what? The reliability. So here, if I will put the value of R value is equal to 0, then I will get one formula, and that formula is, you remember this formula. Reliability, the formula for reliability will become 1 minus P raised to the power N is nothing but reliability, right? This is the reliability formula. Reliability means, for example, we made one bridge, right? We made one bridge. There is one bridge, right? Suppose this bridge is there. Just I'm giving you an example, right? Every time, suppose the water, when the flood occurs, the water reaches up to here only, right? This is the level of water. So using this probability equation, and this water is discharging with some, right? This will go and it will discharge at somewhere. So here, what is the maximum discharge? See, if this is the flood and this flood is coming up to this level, right? And the bridge is here, and through bridge this vehicle passes over. So the maximum QP discharges this one, right? So just by using this formula, reliability formula, we found that how this QP will, when this QP will never cross this bridge height, right? So that is the reliability. Uh, I think it will be clear. Reliability will be clear. Reliability means just we rely on our design that this QP, the highest flood peak, will never cross this bridge where we have designed whatever we have considered, right? So it may never cross, like after, say, after 100 years or 200 years, we have considered the data, and through that data we can say that the reliability, based on this data, the reliability is this. So we can find the reliability by using this formula. 1 minus P raised to the power N is called as reliability. Now one more term is their risk. One more term is their risk. Risk means what? We say that there is a risk of job, there is a risk of life. So here, what is the risk? Risk means, one, when I will reduce the reliability from 1, then I will get the risk. So risk is what? 1 minus reliability. So if a flood will cross the QP, then there is a risk. So if what I given you example is that, suppose this is the bridge, right? And if cross the this QP value, for example, one time has come that the flood has crossed the value of this QP, means the high, this is the, now this QP value has come here, the water is coming over the bridge. So this QP has crossed the bridge, and what is that risk? So that risk is only 1 minus Q raised to the power 1 minus Q raised to the power N. that is risk, formula for risk, right? So you remember this risk formula. Here I think I have already given this. So here this is some C. When R is equal to 2, then the probability of occurrence, this is previous formula for previous formula. I'm talking about a risk. This is what R is equal to this is 1 minus P raised to the, here you will see 1 minus P raised to the power n is the reliability, right? That is called as the reliability. So see, there is two terms. 1 minus C, 1 minus P raised to the power n is what? That is reliability. But what is risk? Risk is the same for, but 1 minus Q raised to the power n, right? So there is a two term, and the difference is 1 minus Q raised to the power n is what? Risk. And 1 minus P raised to the power n is what? Reliability. Reliability. So just don't be confused in this formula. Now, probability of rainfall, what I told you, just probability of rainfall occurrence at least once in a year. So we say that probability means risk is what? Risk is equal to, if I say that probability of rainfall occurrence, for example, is at least once in a year, is once in a year is say n, once in a year, or I say probability of rainfall occurrence is at least once in n year, once in n year, I say this, once in n year. Then it means what? It means risk. Is this okay? I think if somebody and somewhere, if this sentence is used, that suppose this sentence is used, which sentence? Probability of rainfall occurrence at least once in n year means what? It is the nothing but risk, right? So 1 minus, so we will, what we will do? 1 minus p raised to the power 1 minus q raised to the power n. Or if we can also put the value of q, right? So just remember this. If suppose what he is saying, if probability of rainfall occurrence at least two times in n year, then suppose if it is said that probability of occurrence at least 2 in a year, n year, then in this case, see, this 2 times means this value is, r value is equal to 2. So when we will put this value r is equal to 2 in this formula, so here this formula is also given in our PP, this formula, right? When we will put the value of r is equal to 2, right? That is what the probability of occurrence of an event twice in n successive year means. R is equal to 2 means what? Means in 1 year, there is the probability of 2 times of occurrence the same flood in that year or same rainfall in that year, right? If R is equal to 3 means what? That is the probability of occurrence of that flood or rainfall 3 times in a year. So we will just put the value of R in this formula. This is our basic formula just before. In here, in this formula, right? So this is the basic formula, NCR, NCR into P raised to the power R into raised to the power Q into N raised to the power minus R, NCR into P raised to the power R into Q raised to the power N minus R, right? So just we will put the value of R. Sometimes it is 0, sometimes it is equal to 1, sometimes it is equal to 2, and R is equal to 3 means what? At least once in a year in n year, once 2 times in n year, 3 times in n year, right? So when we will put this value, R value, when R value will change, so then here we can get this formula, right? So here they have mentioned R is equal to 2, then they have put the value here, right? When R is equal to 1, they have put the value is equal to R is equal to 1, and when R is equal to 0, then they will put the will get this value, right? This is the formula. Probability is called risk and hence represented by R. R means risk. See, for example, one example is given here. A flood of a certain magnitude has a return period of 25 years. Means what? One flood, there is the chance that that flood will return after 25 years, right? So what is the probability of accidents? Means we can say what is the probability of occurrence, we can say, right? And what is the probability of that flood that may occur in next 12 years? After say 12 years, if it will occur, means R is equal to 12, right? Or see here, first of all, see, we will find first this return period. We know that the return period is denoted by T. This is given as 25, means this T is equal to given as 25. And what is this asking probability? We know that probability is equal to 1 by T, because T is equal to 1 by P. Either I can write this formula or this formula, both are correct. So we want to know probability, that's why we are writing this formula, 1 upon T. So here if I will put the value, so what would be this one? 1 divided by 25, we will get 0.04, means probability is what? 0.04. Means the chances of is 0.04, means see, this is occurring in after say 25 years, means the probability is, we can say, more, right? Now next is the probability of not occurrence. What I told you, we had seen one formula that the probability of not occurrence, and we had seen that Q is equal to 1 minus P, right? But what is that? That is given probability of not occurrence in next 12 year. So 12 year means n is equal to 12. We will put n is equal to 12, and we will put this this value in our formula. What is the probability that is flood may occur in next 12 years. So for that, this formula Qn is equal to 1 minus p raised to the power n. See, probability of not occurrence. We have already find the probability p value is 0.04. Just I will clear it so it should be clear to you. See, first we have find probability is equal to 1 upon t. We have put the value and we got this value. Second question is asked that the probability of not occurrence of a flood in next n successive years is given. So probability of this flood may not occur in, sorry, this is what the probability of that flood which may occur in 12 years. That is may not, that is may occur. I was taking probability of not occurrence. That was wrong. So I have to take what? Probability of occurrence in the next 12 years. So this formula, they have used that, this, the same formula which I have told you, this formula. What is the reliability means that is asking, they are asking the reliability. And we have seen that the reliability formula is this. What is the, this one, this one. So here I have actually mentioned that if a flood will cross the QP value, and the same he is asking if it is exceedance, if it exceeds, what is the probability of that flood may occur in the next 12 years? It means we have to apply this formula, this one. Risk is equal to 1 minus 1 minus, so risk is equal to 1 minus q raised to the power n. I'll check once again. Once again, just wait. What is the probability that is flood may occur in the next 12 years? Means reliability. He is asking reliability. Yes, he is asking reliability. And reliability, we have seen the formula. Reliability is equal to 1 minus p raised to the power n. We had seen this. So we will put the value of p, and for how many years? After here 12 years. So n value is equal to 12. So they have put this value and they get that 0.613. Now, once we got this reliability, what next is they are getting that probability of occurrence of this flood at least once in next 12 years. And this R is equal to what? We had seen this R value is what? Risk. R is the risk, right? So R is the risk means what? Risk is nothing but 1 minus this P. This P means this one which we have got. So 1 minus 0.613, we will get 0.387. This is what? This is the risk. Now there is another problem. We'll see this also. On the basis of isopluvial maps, the 50 years 2020 the 50 years of 24-hour maximum rainfall at Bangalore. This is one of the city in India, is found as 16 centimeter. Means in 50 years, in 50 years, one in 24-hour rainfall was recorded in the Bangalore city, right? In the Bangalore city, and that rainfall was 16 centimeter. This is how much? 160 mm, right? In last 50 years. Determine the probability of 24-hour rainfall of magnitude equal to great or equal to or greater than 16 centimeter of occurring at Bangalore. Now, we have to find the probability, means p-value, after how long we can, what would be this p-value? Means this 50-year flood, the probability is how much? So probability is, say, if it is 50-year, means it is the discharge, or we can say the flood value is very high, but the chances is very less, right? So here we know that this 50-year means this t value is given. We know that p is equal to what? P is equal to 1 upon t. If I will put this value 1 upon 50, I will get this value, that is the probability, p value. Now, what he is asking, first to find at least once in 10 successive years. Means, for example, in every 10 years, for example, he's asking after say 10 years, then after 10 years, then after 10 years, what is the probability of occurrence? So what they are doing, they are using this formula, that is R is equal to 1 minus 1 minus p raised to the power n. 1 minus p raised to the power n means risk. This is the formula, is risk. So first is, what is the risk? So let's see, after 10 years, they put the value of 10 first, because they are asking once in 10 successive years. So they will put just the, in the risk formula, that is p already we got this value, and n value we will put here. So we will get the value of risk in 10 years. Here you will see that if we put the value of first value 10 years, so what is this? Risk is 0.183%. Now, 2 times in 10 successive years. Now, what he is asking, what is the chances of occurrence of this flood in the next, again in the 10 year, but what is that? After immediately, say 2 times in a year. First it is once in a like once in a year, then 2 times in a year. So here you will see that here what they are doing, just simply see. So we got first this probability of occurrence in n years just 1 time, but when we have to find just for 2 times, so what I told you, that they have put the value of r is equal to 2 in the basic formula, that is the n factorial upon n minus 2 factorial into 2 factorial into p square into q raised to the power n minus 1. So here n factorial, n means what? 10 after 10 years, so 10 value, and 10 minus 2, that is 8 factorial into 2 factorial means 2 into 1. 8 factorial means 8 into, we have already know that, we know this, right? Now p value we already got 0.02. Now what is the value of q? So we know that what is the small value of q, how we find the small value of q. So for that, the formula for a small finding the small value, that q already we have seen. Yes, if you remember, q is equal to 1 minus p, right? We know this formula. So through this formula we will get the value of q, and when we will put this value here we will get the uh, occurrence of that flood in 10 years but in 2 times. Then what is the another question they are asked? Third, C, once in 10 successive years. Probability of accidents once in an year is given by the equation. P1 into n into p raised to the power q into raised to the power n minus 1. N is the value, n is the number of years. So here n is what? 10, p is 0.02, and q value we know that, and again n minus 1 means 10 minus 1. So here we will get the probability of accidents once in a year, means it can be exceed more than one year, more than one in a year, in 10 years. See, there is a difference, a small difference. If you will read the word of the problem, see here. See, at least once in 10 successive years. And here, what is that? Once in 10 successive years. But there may be the chances that it may be more than one, right? But here, minimum one. And here, it may be more than one. And here, it is already confirmed that 2 times in 10 successive years. So there is a small difference of the wording. So here you have to check. No. So we got this. Now, next problem is that what return period you would adopt in the design of a culvert on a drain if you are allowed to accept only 5% risk of floodings. Now, see, risk means what? We know risk is R. R, we know risk is spelling is RISK, risk. So you remember that risk means R, and R is equal to 1 minus, right? And again 1 minus p raised to the power n, right? You simply remember. Now, what the value is given as? Allowed to accept only the 5% risk. 5% means what? R is equal to 5%. 5% means 5 divided by 100. Now, flooding in 25 years. Next coming 25 years mean n value is equal to what? 25. N is equal to 25. What would be the return period? Return period means we have to find the t value. Now, first what we will find? First we will find, because the risk is given and the return period is given. So first we will find probability, and probability is equal to what? 1 upon t. So through that we will get the value of p. Once we will get the value of p, we will put this value here, right? And n value is already, we know that 25 years. So here you can see the step 1 is p is equal to 1 by t, and n is equal to 25 years. Then we will put this value in our formula. A risk already, that is already given. So we will put all value in our formula, and we will get the value of this return period. So just you check. Risk formula is this one. First they find the risk is given, Probability we don't know, but t is value is given. So 1 upon t, t means return period, and this n is the 25 years. So first of all, we will put this all values. So in the risk formula, see here, you will see that we don't know the value of, just check once again what I'm saying you. We know that P is equal to 1 by T, right? And R value we know. So here the value of this P value is we don't know, because we have to find the T value, and T value we don't know. Once we will get the T, we will find the P. So through this formula, which formula? This formula. R is equal to 1 minus, and again 1 minus P raised to the power n. N is 25, P we don't know, R, this is 1 minus again 1, and this R value is 0.05. So here if we will solve it, we will get the value of P is equal to this value, not P value. 1 minus P raised to the power 25 value is equal to 0.95, right? So if I will solve it again, 1 minus P is equal to 1 minus P is equal to C. 1 minus P raised to the power 25 is equal to 0.95, right? I want value of P. So when I will do this, 1 minus P is equal to what will become? It will become 0.95 raised to the power 1 divided by 25, right? It will be reverse of this. Now once I will calculate this value, then I know what this is, 1 minus P. Then P will be equal to what? Whatever the value we'll get here, it will come here, and this P value will go here. So we will get the value of P is 0.00205, and we know that T is equal to 1 upon P. So I will put this P value here, and I will get the T value. Means the same type of flood may be that may come after 488 years with same type of magnitude. So as the value is high, the we can say chances is also, we can say, of the return period is safe so far. Now, is there anything other asked? Now, once we know this value, this is one of the formula. Actually, it is missed. It has come here. It should, this slide should come here, somewhere here, where we have given the formula. Where we have given the formula, like I think here. No, this formula. It is also not. Yes, somewhere here it should come somewhere here. After this, it should come somewhere here, right? This one. Actually, no, it should come somewhere here, I think. Then it is okay, right? So here, so we got this value now. See here what I discussed. Suppose when some data is given, for example, here the question is given that flood frequency records on a river have been collected for 17 years, starting from 1951 to 1967, and the peak values of the flood observed during the each of these 17 years, means this 17 years data is available. So that starts from 1951 to 1967. Suppose in 1951, There may be suppose 20 year 20 data, total 20 data. In 20 out of 20 data means in 1 year, suppose sometimes some peak discharge came, suppose something 10, for example, then 10, 20, then 5, then 3, then 4, likewise. So out of this data, there will be some one big data, for example, this 20. So that 20 represents the highest data of this 1951. The same data is suppose here given. Similarly, for 1952, there may be the number of data, but highest data is given, right? So for every year, the highest data of peak flood is given. So that is almost for 17 years data. Now estimate the magnitude of flood having frequency equal to 80 years means what we have to find, estimate the magnitude of flood having the frequency equal to 80 years. Means the flood which will have the frequency of 80 years means the flood which will come after 80 years. Frequency means suppose something is occurring, for example, some ball is there and it is coming on the floor and again it is going. And this ball, in 1 second, suppose this ball again go back. In 1 second, suppose this ball go for at least 4 times in 1 second. So this is the frequency. Similarly, if any flood is there and if that flood comes, then that the frequency of that flood is given as, so after 80 years, and what would be the magnitude? We have to find the magnitude. Means after 80 years, what would be the Q value or what would be the rainfall value of that year, right? We have to find. Then after 400 years, what would be the peak value of the flood observed during these 17 years? So first of all, what they will do, from 1951 to 1967, the some data is given. Somewhere it is 3,000, 4,400, 6,000. Then again something small, likewise, right? Somewhere it is big value, somewhere is very small value. What I told you, that first thing what we will do when we will start the solution, right? This is some this given. The solution is that first we will arrange in a sequential manner. Sequential manner means what? Highest value, see this 9,000 will come first, right? This highest value will come first. Then below that 9,000, the another value will come, right? 6,700, then 6,000, then 5,400, likewise. And we will see this 9,000 is the highest. So that's why the M value or grade or rank, we can say, rank will be 1, then 2, 3, 4, 5, likewise, their rank will be there. Then we know that the formula for T is equal to what? N upon M. So what is total N? N value means how many value? 1, 2, how many values are here? 17. So N value is equal to what? 17. So here you can see that this N value is already mentioned as is equal to 17. Now we have given the rank. So for different floods, the rank value is different, right? For different floods, yes, for different floods, the rank value is different. This is first, this is second, likewise. The rank of this flood is what? Sixth. The rank of 1965 flood 4,000 is the rank is at 10th. Now, once we know that rank means this M value. M is equal to 1, M is equal to 2, M is equal to 3, then M is equal to 4, likewise. So through this n upon m, we will get the value of t, return period, right? Return period, we know the frequency. Return period is nothing but the frequency. We will get this. Once we know that, then we have to find the what is the chances. Chances means just what we are doing actually. Chances of that flood. So obviously we know that this which the flood which is having the highest discharge value or Q value, the chances will be less, right? So simply we can say the probability P will be equal to what? This P value equal to, we know that 1 upon T, right? The probability will be very small for that. As we will go down, the probability will be increased, right? You will see this, it is increasing, right? Means the as the probability, the T value is, as the T value is decreasing, it is going down, the P value is increasing, right? So there, I hope that it is clear to you. So they have calculated this until, so they arranged in the, see, they arranged in the sequential manner. They calculated P value. Now, after that, you will observe that here the flood which is having the frequency is around how much? 80%. Here, we'll read it. So these chances are means probability we have occurred in the fifth column. The magnitude of flood having the frequency of 80 years means which flood, the flood which will repeat after 80 years, or the probability is 80 years, means what is that? 1.25. See, 100 divided by 80 means, or we can say 80 divided by 100 means what? 80 divided by 100 means what? There is the multiplied by 100. If we will do this, sorry, not this one, 100 divided by 80, right? See, if 100 divided by 100 means what? This will be cancelled only 1%, right? So the the flood which is having the value of 1.25, what is that value? Here you see this, just concentrate here. 1.25 means where is this? It is somewhere here, right? Means its chances 82.4, we can say that is 1.2. So here, if you will see that, directly read. What they have done, see here, based on this data, what they did actually, they have drawn on simple graph paper. They have taken this data, right? And they have taken on x and y axis. On x-axis and on y-axis, if you will see this, directly I am going here. Using this data, whatever they got this value here, right? They use this data and they draw this graph, right? So on y-axis, they have taken the value of Q in meter cube per second. And on x-axis, they have taken the percentage chances. we can say, or the percentage chances in percentage, we can say. So here from 0 to 100, they have drawn a graph. And then what they did, for example, if you will see this is 10, this is 0 means 5 is some area. If I will again half, if I will do again half, it will be what, 2.5. And again, if I will do half, means there is the some value. That value is what? That is the chances or percentage. There is 1.25, 1.25 chance percentage here, this one. Chance percentage. They have taken on x-axis, right? So here, where is 1.25? Because we have only the 5.9 value, right? And based on that, and so based on this value, they draw one graph, and this says that if the chance is 1.25%, means 11,000 meter cube discharge may come. See here. The magnitude of a flood having the frequency of 80 years. 80 years. This chance percentage is how much? Means 100 divided by 80. If I ask you the magnitude of having the frequency of say 70 years, 70 years means 100. If I will divide 100 by 70, I will get some value. What value I will get? I will get, suppose, 100 divided by 70. I will get it as a 1.42, right? 1.42. Similarly, 100 divided by 80 is how much? It is getting 1.25%. 1.25% is kya? What is that? That is the percentage chance, right? Similarly, 1.42 means what? Chance percentage. Chance percentage. Chances of occurring that flood. Similarly, if somebody says that 400 years, 400 in of frequency say 400. So the same thing, the magnitude of flood having the frequency of 400 years means the flood which can come after 400 years. What is the chance of that 400? So what they have done, 100 divided by 400, right? So they will get 0.25. The chances is only 0.25, right? So 0.25, where it is coming in the graph, we will see 0.25. Here, if you will see 0.25 is very somewhere little, it will come somewhere here. It is very, very like this data, right? So you will see that it will come around somewhere here. Somewhere it is coming somewhere here. And this data was what? That was for 80 years. And this is for what? This is 400 years. And how we are finding based on the data which is available for 17 years, right? I hope this will be clear to you. Now, this is what, this is the flood frequency chapter. So some such type of question may be asked. So if you have any doubt, you can ask. Here I stop this lecture.